Okay, so 1.7 notes. We are looking at special cases of having variables on both sides. So on Friday in here, we looked at when we have variables on both sides. This is going to be special cases of that. And I will show you what happens with those special cases here momentarily. But basically, we know what to do when there's variables on both sides, but then there's something that funky that happens. But the funky thing that happens actually ends up being way less work for you guys. So it actually ends up benefiting you. You just have to know what to do with it. Okay. Today, instead of taking a few notes at the beginning and then doing 4 examples, we're going to do 4 examples and then take a few notes at the end. So I am going to go ahead and split my page. I'm going to leave like 5 lines at the end. And I'm going to split the rest of my page. I guess I can draw a line here too. So I'm going to do 1, 2, 3, 4 examples and then take a few little notes at the end about what these special cases are and what they each mean. Okay. First example that we are going to do is, in this first box here, 3 times the quantity 4x plus 6 equals 8x plus 38. Okay, with this first example, the very first thing that I need to do is distribute. So I'm going to distribute that 3. So I'm going to do 3 to 4x, 3 to 6. 3 times 4 is 12. So I have 12x. And 3 times 6 is 18. So I have plus 18. And then there's nothing I need to do on the right side of that equation yet. I just have 8x plus 38. I guess I could. Just kidding. I could airplay this and still record here, but you guys can see that fine, so I'm not going to mess with it. Okay. From there, we are going to get x all on one side of our equation. Is it easier to do 12x minus 8x or 8x minus 12x? What's easier, 12 minus 8 or 8 minus 12?
8 minus 12.
What's 8 minus 12? 12 minus 8 is 4. 8 minus 12 is negative 4. I would do minus 8x on both sides. Either way, you should get the correct answer. But if you do minus 8x on both sides, you're going to avoid some negatives. So 12 minus 8 is 4. So I've got 4x plus 18 on the left. On the right side, I just have 38. And then from there, I just solve it like a normal two-step equation. I'm going to subtract 18 from both sides. End up with 4x equals 38 minus 18. 38 minus 18 is 20. And then I divide both sides by 4. I get x equals 5. Oh, that was weird. Okay, apparently it's not going to let me make an oval nicely. There we go. Okay, so this example was actually just like what we did back on Friday. Distribute on both sides, move all of your variables to one side, solve, you get an answer. Any questions about that before we move on? Okay, nice stuff like that isn't always going to happen. We have some special things that might happen, but they actually end up being less work for us. So let's talk about those. Next example I have for you guys is 2x plus 4 plus 3x equals 7x minus 2x plus 6. On the left side, I'm going to combine together 2 and 3, so 2x and 3x, and I will get 5x. So these combine together to be 5x plus 4 equals. And on the right side, I've got 7x minus 2x. 7 minus 2 is 5, so I've got 5x plus 6 on the right. Do you have your notebook? It should be open. Okay. From there, I now have to decide whether I want to subtract 5x from both sides or subtract 5x from both sides. But since it's the same, it doesn't matter. So I'm going to subtract 5x from both sides. So I have minus 5x on the left, I have minus 5x on the right. Because my goal at this point is to move all of my x's to one side of my equation. So I'm going to cancel these out. Oh, just kidding. I didn't mean to erase. I meant to cancel. Cancel those out. I just have 4 on the left side of my equation. On the right side, 5x minus 5x cancels as well, and I just have 6. So in my equation, all of my x's cancel out on each side, and I am left with the statement 4 equals 6. So what has happened here is that my variables have disappeared because they all canceled out. They were even with each other on each side. They canceled out. Any questions about my variables disappearing? Okay, from here, we then have to look at the statement that we are left with, and we have to decide whether it is true or false. Does 4 equal 6? No. So it is a false statement. I'm going to write false just so I know that that's why it's going to be no solutions. And our answer here is going to be no solution. That means that there is no possible number for x that we could plug in that would make this equation true. Because any number that we plug in, the x's on each side would cancel each other out, and we would be left with 4 equals 6, which will never be true. So if this happens in an equation, you are going to end up writing no solutions. You do need to show your work up until when your variables cancel out and write no solution. I always abbreviate solution to SOL because solution is a long word. Okay, any questions about that one? Okay, moving on. And see, it ends up being less work. You don't have to actually solve it out. Next one I've got for you guys is 4x minus 32 equals 4 times the quantity x minus 8. All right, first thing that I need to do in this one is distribute on both sides. So I'm going to distribute on the left here. Just kidding, not on the left, on the right. 4 times x, 4 times negative 8. So the left stays 4x minus 32. And on the right side, 4 times x is 4x. 4 times negative 8 is minus 32. From there, we can subtract 4x from both sides, which will cancel out on both sides. I will be left with negative 32 on the left side of the equation and negative 32 on the right side of the equation. Because my 4x's cancel out, so I'm left with negative 32 equals negative 32. Okay. Then from there, I am left with that statement. I determine that that statement is true because negative 32 does equal negative 32. And therefore, my solution is any number in the entire world. I could literally plug in anything, and this would be true. If I did 4 times 5 minus 32 equals 4 times the quantity of 5 minus 8. And so I just picked a random number 5. plug that in, it'll work. If I plugged in 145, it would work. If I plugged in 936, it would work. So any number that I plug into this, as long as I plug in the same x on both sides, will make this equation true. That means I have an infinite number of solutions. You have two options for writing infinite solutions. You can write I in F, so you can write out infinite solutions if you want. I'm not going to do that. So you can write I in F, SOL. So just abbreviate infinite and abbreviate solution. Or you can use an infinity sign. So either of those would be acceptable. Okay. Any questions right now? I have one last example for you guys because we've seen in no solutions, we've seen in infinite solutions. There's something weird that happens that's not either of these, and sometimes people get them confused, so I just want to tell you ahead of time. Then we're going to make a little chart of which one's which. Okay, last problem I've got for you guys is 4x plus 15 minus 2x equals 3 times the quantity 2x plus 5. In this one, we're going to need to combine like terms on the left, and we're going to need to distribute on the right. So I'm going to combine like terms, 4x minus 2x. 4 minus 2 is 2, so I've got 2x plus 15 equals 3 times 2x is 6x. 3 times 5 is 15. Okay. Then, next thing that we want to do is we want to get all of our variables on one side of the equation or the other. So, I can either subtract 2x from both sides or I can subtract 6x from both sides. I think it's easier to subtract 2x because then I'll keep positive numbers. I'm going to do minus 2x on both sides. On the left side, those cancel, so that leaves behind just 15. On the right side, 6x minus 2x is 4x plus 15. Okay. From there, I solve it just like a normal two-step equation. Only thing that's different is that on the left side of my equation is my number and my x is on the right side of my equation. But either way, I'm going to subtract 15 from both sides. 15 minus 15 on the left cancels out. When everything on one side of an equation cancels out and we're left with nothing, we need to make sure we put a 0 there. So I've got 0 equals 4x. I can divide both sides by 4. 0 divided by 4 is 0. So I get 0 equals x, which I can flip around to be x equals 0. The reason why I wanted to include this equation is because now that we have in our minds that no solutions can happen, when we get 0, we think that means no solutions. 0 is a solution. It's a number, x equals 0. So x equals 0 still is a possible answer that you can get. Don't think just because 0 means nothing that you have no solutions. You do have a solution, just one. It's x equals 0. Okay, any questions right now? Okay, down here at the bottom, I just want to write one little thing, and that is what happens if your variables disappear, to just kind of put it all in one spot. So if your variables disappear, you then look at your statement, and one of two things happens. If it's true, that means you have infinite solutions. And if the statement you're left with is false, that means you have no solutions. So that's the new part of today, is if your variables disappear, determining what happens. Okay. Questions right now. I'm going to go ahead and stop this video. You guys have your assignment to work on that I'm going to bring around right now. It has 9 problems on it. 3 of them are going to have a solution. 3 of them are going to have no solutions. 3 of them are going to have infinite solutions. So that means for 6 of the 9 problems on there, you don't have to finish solving it out. Because once you get to just a number on each side and your variables cancel out, you can just determine whether it's no or infinite.